Okay, guys. Now there's a question here. We have a rough horizontal surface here. There's a triangle, and all its sides are given. Like it's basically a triangular prism. It's a solid over here. Okay. There's a force X applied to the top edge here. Okay. And we have to determine that if this breaks the equilibrium, that means if it slides or topples. Okay. So let's do the first case here when X is 1 over 5 mg and mu is 3 over 4. Okay, bacho. So we have the horizontal forces right now here. Your X is equal to F because we are given that there is a, this is like, this is resting over here. There is a state of equilibrium here. Okay. Now, and then um, the vertical forces I have, there is its weight mg, and there is this upward r over here. So this r is equal to mg. Now since we're going to deal with the first case here, we have X equal to 1 over 5 mg, and we're given mu equal to 3 over 4. Now from this, so we can determine its limiting friction. That is going to be, your R is equal to mg. So this is going to be 3 over 4 mg. That is your limiting friction. Okay, the friction cannot go past this value 3 over 4 mg. Acha. Now let us find the moments about O. Finding moments about O. Okay, and sometimes we have many options to find the moments about. Since you people have an idea, okay, when you're applying this force onto this edge, so this is the point about which this would be toppling. Okay, so now when you start applying the force X over here, and if you start increasing this, so this distance D would start decreasing, okay, from this point over here. Acha, now when you have to find the moments about O, so you should be clear about the center of mass of this um, triangular cross section over here. Okay. Now let me do it here. Let me do that separately here. We have this triangular cross section. Okay. So if I take this point as, since I'm going to, it's up to you. You can take it from any of the points. So let's take this point. Let me take this as 0, 0 here. Okay. And this point will be, this length is a, I think. Yeah, this will be minus a comma 0. This will be minus a comma 2a. Okay. Now uh, the center of mass would be somewhere over here. Remember, it is x1 plus x2 plus x3 over 3, comma y1 plus y2 plus y3 over 3 in case of a triangular lamina. Okay, so we have 0 minus a minus, this is going to be minus 2a over 3 from this O, okay? And then this is going to be 2a over 3 as well, okay? So this distance, when I have to find these moments, so let me use a different color here. This distance over here, this distance is going to be 2a over 3. And this distance is also 2a over 3. Guys, do you agree with this or not? Hmm? Hurry up.
Yes.
Okay, bacho.
Yes.
Now, when we find the moments about this point O, so we have these, this R is going to be creating a moment like this X is going to create a moment like this, and this weight is going to create a moment like this. That is going to be, I think this is your anti-clockwise, and these two are clockwise. So R times D, I have R times D plus x times 2a, x times 2a,
Yes.
that is going to be equal to mg times
Sir,
that.
but you won't add r into d and x into 2a because r is vertical and r is horizontal. So x is horizontal.
Beta, this is, I'm not adding up the forces, I'm adding up the moments. I'm adding the clockwise moments
Oh,
and
okay,
putting that
okay.
equal to the anti-clockwise moment. Okay. So that is going to be mg times 2a over 3. Okay. This is mg times 2a over 3. Acha, if I put that x as 1 over 5. Okay. So this is going to be R, we have equal to mg na? Yeah, this is mg times d plus 1 over 5 mg times 2a, and that is going to be equal to 2 by 3 mg times a. We have to basically determine the value of d. If this d happens to be 0, this would mean it is going to topple when your x is 1 over 5 mg. So guys, what do you get your d as here? Can you find me that? This is going to be 2 over 3 minus uh, 1 over 5. Please do that. 2 over 3 minus 1 over 5 mga divided by this mg. Okay, mg cancel by this mg. Is this d equal to 0? Hmm? Is this equal to 0?
No.
No. That means it is not going to topple when your x is equal to 1 over 5.
Sir,
Yes, beta.
sir,
Mm-hmm.
inside the bracket, won't it be 2 over 3 minus 2 over 5 because
Yes,
there is
yes,
a 2
yes,
with
yes,
2a?
yes, yes, yes. I just ignored this too. Thank you, beta. Thank you, thank you. So you are basically you're working this while listening to me. So that is why you got this thing. Okay. Acha, bacho, so since this d is not equal to 0, therefore it is not going to topple. So d is not equal to 0, so it is not going to topple. Okay. Now let's see next thing. Your x is equal to f. You have this coefficient of friction, and we have determined that f is going to be 3 over 4 mg. Now, this x should be more than 3 over 4 mg if it has to slide. Your x is 1 over 5 mg. Is that more than 3 over 4 mg? Yes or no? Hmm? Hurry
No,
up. No? So this
no.
means this will not slide as well. So this is neither going to slide nor going to topple because your friction has not been overcome by this applied force over here. Okay? The friction has not been overcome by this applied horizontal force over here. So if this x was more than 3 over 4 mg, only then this could have slided. Okay? Now you people have the same question here. You check this, you try this for the part B. So we are into another complicated situation here. We have been given a solid uniform cone of base radius r and height 4r. It is placed on a rough plane inclined at an angle theta as shown in the diagram. The coefficient of friction between the cone and the plane is zero point 0.5. We're given this mu as zero point 0.5. The plane is hinged at the bottom. I have shown this hinge here, and it is slowly rotated so that theta increases. Giving a justification for your answer, determine whether or not the cone topples before it slides. So basically, we have to find two thetas here. We have to find the theta if it slides. We have to find the theta if it is going to topple. So whichever theta is smaller, so that means that thing is going to happen first. So that is our plan of action. Okay. So let us resolve the forces. By the way, we know that its center of mass from here would be at 3r, है ना? यहाँ पे this much is 3r, and this distance is going to be r from this inclined surface. ठीक है ना? So this is 3r and this is going to be r. So here is the center of mass. Let me call this point X. ठीक है? अच्छा. So let's see what forces we have right now
Haven't we
here.
already resolved the forces one?
We'll have to resolve the forces, beta. We'll have to. I'm
They've
going.
already solved the forces.
What Shazreen? क्या कह रहे हो?